right? This next factoring method, this next trinomial factoring method is called completing the square. And at first glance, it might look like it's like the previous one that we did, which was trinomial factoring using C. And C was the constant term in the trinomial. That also is when the leading coefficient was equal to 1. But you use completing the square when that previous factoring method fails. Okay, so when using C method does not work, you use this completing the square method. This is useful when converting a second degree trinomial into a reference form for graphing it. All right, so here we've got a second degree polynomial. Okay, this is a trinomial because there's 3 terms, such that let me take that out, such that the leading coefficient is 1 and the previous factoring method fails. So again, this looks like what we did before. But if the previous method fails, what that means is that you looked to see if there were 2 factors of the constant term, right? J and K, and you looked at all the possibilities to see factors that will give you this constant term, and you added them together to see if that would be equal to this second term, the coefficient of the second term, B. And you couldn't find one. Okay, that wasn't possible. So that factoring method fails. So what do? You can use the completing the square method. So the completing the square method, what you do is you take the coefficient of the second term and you divide it by 2. And you take this coefficient of the second term divided by 2, and you take the square of that, and you both add it and subtract it to the polynomial at the same time. Now, kind of look at what this is doing. All right, let's say, for example, we had x squared plus 2x, and we had plus 9 over here. Okay, and if we decided to add 1 and subtract 1 to this, well, this adds up to 0. So by adding 1 and subtracting 1, we haven't changed the value of this original expression, right? So that's essentially what we've done, is we've added a value and we're subtracting that same value. So together, that adds up to 0. Okay, but what this will do is this will allow us to create a factorization, okay, out of it. So this is part of the process. And this is, the reason why it works. All right. So, when you take the coefficient of the second term and you divide it in half and you square it and you add that and subtract it from this expression, then you're left with a factorization that looks like this. So you have x plus b over 2 squared minus b over 2 squared plus c. So notice this minus b over 2 squared c, that's this part of it. And then this perfect square that you made is this squared factorization that you made out of the first 2 terms. Okay. So let's again take a look at an example of this factoring method using something concrete, because again, with all of this, it's rather abstract. So let's do this using an example here. All right. So given x squared plus 10x plus 18. So the first thing to look at, maybe, let's just see if we could actually get this to work with the previous method, right? 18, we could have 1 times 18. to give us positive 18. We have -1, -18. We could have 2 times 9 and -2 times -9. We could have 3 times 6 and -3 times -6. But you can see there's no combination of adding these together. There's no combination of adding these together. They're going to give us a positive 10, right? So none of these are not going to give us positive 10. So that's where the C method fails. Okay, and we have to use this completing the square method. You know, it looks relatively simple and it looks like straightforward. We should be able to use that previous method, but we can't. It just won't work. All right. So what we do is we take the coefficient in the second term, all right, and we divide it by 2, like that. And then we can rewrite this as x squared plus 10x. So here, that's going to be equal to 5. Okay, so that's going to be plus 5 squared minus 5 squared. And then we have plus 18. Okay, so we took the first two terms. Okay, then we added b over 2 squared. We added b over 2 squared. Then we subtracted b over 2 squared. And then we added in the third term. All right, and what that's going to let us do is it's going to let us write the first two terms plus this b over 2 squared. We'll be able to write that as x plus 5 squared, and that's going to be minus 5 squared plus 18. So by adding this 5 squared and subtracting this 5 squared, we've created a new trinomial, which is a perfect square. And now we just need to simplify this a little bit more. So this is going to be negative 25 plus 18. So we're going to have x plus 5 squared minus 7. So this is the factored form of this original trinomial here. All right. Now let's look at this think, pair, share. I would pause the video and try this on your own. This is the answer that you should get. But let's take a look at that. So pause now, come back if you want to see my solution to this. All right, so this is going to fail, okay, the previous method. So what we need to do is look at it in terms of this new method. So we've got x squared minus 18x, so negative 18. Or let's see here. Yeah, it won't matter. Okay, so our value of b is 18. So we're going to have negative 18 plus, let me make that a negative. Okay, we have negative 18 over 2 squared minus negative 18 over 2 squared plus 44. All right, let's try and simplify some things here. We've got x squared minus 18x plus, this is going to be what? Negative 9 squared minus a negative 9 squared plus 44. Okay, so this trinomial is going to be x minus 9 squared, like that. And let's see, we've got minus, so negative 9 squared is going to be positive 81. And so we've got a negative 81 plus a positive 44. And that gives us a negative 37. Yeah. Okay. So this is how you would complete the square for this trinomial, which fails the previous factoring method. All right, let me know if you have any questions.